Welcome to the session. In this session, we will review the basic formulae of arithmetic progressions and we'll also look at some various examples. Let's begin. So we know what an arithmetic progression is. This is the formula for the nth term. So a is the first term and d is a common difference and n is the number of terms. The formula for the sum, you can also review that, and there are two ways of writing it. The second formula says that you can take the average of the first term and the last term and multiply that with the number of terms to get the sum of the AP. Finally, when we have to take three terms in AP, we should take them as A minus D, A and A plus D. If we have to take 5 terms in AP, we can similarly add A plus 2D and A minus 2D to either side. Alright, if 3 numbers are given to be in AP, then we can take them as ABC and then twice the middle term will be equal to the first term plus the third term. Let's look at now at some examples. So here's the first example. We have been given that TR is the rth term of an AP, and for M and N we have Tm is equal to 1 by N and Tn is equal to 1 by M. So we have to find out the M nth term of this same AP. How do we do this question? Okay, let us say that the first term is A and the common difference is D. Then the mth term can be written in this form. It is given to be 1 by N, so we equate it to 1 by N. The nth term can also be written down and equated to 1 by M. So we have two equations and there are two variables over here, A and D. So when we subtract these two equations, we will find that A would cancel out and we get this form now. Now the right hand side can be simplified to this form and we can see that we can cancel out M minus N on both sides. So that leads to D equals 1 divided by Mn. Now if we take this value of D and plug in into either equation 1 or 2, we can find that A is also 1 by Mn, which means the Mnth term, which would be in this form, can now be found. So we put the values for D and A and we find that the entire thing just simplifies to 1. And therefore the answer is option C. Take a moment to read this question. It says that the number of terms in an AP is even and the sum of the odd terms is 24 and the sum of the even terms is 30. It's also given that the last term is greater than the first term by 10 and 1/2. Now we have to find out how many terms are there in this AP. So how do we do this question? Let us say that the number of terms in the AP is 2n and the common difference of this AP is D. Now the last term is obviously equal to the first term plus 2n minus 1d. That's a standard formula. It's given that the last term minus the first term is 10.5, so we equate it to that, and that gives us one equation. So 21 over 2 is 2n minus 1 times d. Let us take the odd terms of this progression now. So those are a1, a3 right up to an minus 1. We can also see that there would be n odd terms, and the common difference of those odd terms would be 2d. Therefore, the sum of the odd terms would be given by this formula. So you can see that we have used the common difference as 2d now and not d. And this sum is given to be 24. So this gives us another equation. Let us consider the even terms now. So they also form an arithmetic progression and the common difference is 2d. So the sum of the even terms, for that we can use this formula and that is equal to 30. This gives us one more equation. Now subtracting equations 2 from equation 3, we can find that 30 minus 24 is 6. So that shows up on the left hand side. And on the right hand side, we find that the n minus 1 times 2d terms cancel out. So this is what we're left with. Now a2 minus a1 is the common difference. So we can say that 6 is equal to nd. So that's another equation. And combining this with the first equation, we can now solve for n and d. So the value of n is 4. And therefore, the number of terms in this progression is 2n, which is equal to 8. The correct answer is option A. Okay, take a moment to read the question. It says that there is an AP whose terms are all positive, and the sum of the first 9 terms is between 200 and 220. It's also given that the second term is 12, and we have to find out the fourth term. How do we do this question? So let's take the first 9 terms in this form. So the advantage of taking the terms in this form is that when we add them, the d terms would cancel out and we can say that the sum is just 9a. It's given that 9a lies between 200 and 220, which means A would lie between 22.22 and 24.44. So the possible integral values of A are 23 and 24. Now suppose we take that A is 23. So that would lead to the second term, which is A minus 3D, to be equal to 12. And that gives D as 11 over 3. And that's not allowed because all the terms are supposed to be integers. So we reject the value A equals 23. Let us say that A is 24. Then the formula we are going to get is that 3A should be equal to A minus 12. That means D is 4 now. And this is acceptable because now we are going to get all integral values. Therefore, the fourth term which we can see from this line is A minus D. That would be equal to 24 minus 4, and that's 20. So the correct answer here is option C. Okay, take a moment to read the question. So 3 numbers are given to be consecutive terms of an AP, and we need to find out that this is possible for how many values of X. How do we do this question? Okay, so using the fact that 3 numbers A, B, C are in AP, we can say that twice the middle term will be equal to the first term plus the third term. That means 2 times log of 2 to the x minus 1 to base 10 would be equal to log of 2 plus log of 2 to the x plus 3 to the base 10. So using the properties of log, we can simplify both sides and write it in this manner. Now we can say that log to base 10 can be removed from both sides, and we can just get this equation, which we need to solve now. So we'll call 2 to the x as t, and we are going to get now an equation which just contains t. And that's a quadratic equation which can be brought down to this form. Now, factorizing this equation, we find that the values of t are 5 and negative 1. So because t is 2 to the x, we can say that 2 to the x is either 5 or 2 to the x is negative 1. Now 2 to the x cannot be negative, so this one has to be rejected. And only 2 to the x equals 5 can be accepted. Therefore, there's only one value of x which is going to satisfy this equation. The correct answer is option C. Take a moment to read the question. There's an AP given, and it's given that the ratio of 2 sums of this AP is equal to P cubed divided by Q cubed. The numerator is the sum of the first P terms and the denominator is the sum of the first Q terms. We have to find out the ratio of the 6th and the 21st term. How do we do this question? First of all, using the formula for the sum of an AP, we can write down the given condition in this form. And we can see that P and Q would be cancelled out from both sides, and we can simplify the condition to this form. Now if we divide the left hand side in the numerator and the denominator by 2, we can write it like this. Now this is suggestive because it tells us that because we're looking for the ratio of the 6th and the 21st term, we can take P minus 1 to be 5 and Q minus 1 over 2 to be 20. And that gives us P is equal to 11 and Q is equal to 41. So this is the ratio that we're looking for now. Now plugging in the values for P and Q, we find that the answer is 11 squared by 41 squared, which is 121 by 1681. And the correct answer therefore is option B. Here's a quick recap of all the standard formulae which you already know. So the formula for the nth term, the formula for the sum of an AP, and if you have to take 3 terms or 5 terms or 7 terms in an AP, you know how to take them. And if 3 numbers are in AP, then twice the middle one is equal to the first term plus the third one. Let's look at some examples now. So here's the first one, and it says that 100 times the 100th term is equal to 50 times the 50th term. And we need to find out the 150th term of this AP. How do we do this question? So we take the first term as A and the common difference as D and write down the condition in this manner. So 100 times the 100th term is 50 times the 50th term. Now simplifying it leads us to these equations, and taking all the terms to the left hand side, we find that A plus 149D is equal to 0. Now what about the 150th term? That's just A plus 149D. So that means the 150th term, which is A plus 149D, should also be 0. The correct answer therefore is option D. Take a moment to read the question. So this is an AP which is given to us, and the difference of A4 minus A7 plus A10 is equal to M. We have to find out the sum of the first 13 terms of this AP and we have to find out the answer in terms of m. How do we do this question? Let's call the first term a1 as a and the common difference as d. So a4 minus a7 plus a10 is equal to m. Now a4 is a plus 3d and a7 would be a plus 6d. a10 would be a plus 9d. So we replace all of that over here and simplify this entire expression to get a plus 6d is equal to m. Now the sum of the first 13 terms would be 13 divided by 2 times 2a plus 12 can be simplified to 13 times a plus 6d. So a plus 6d is m, so that gives us 13m as the answer. The correct answer is option C. Take a moment to read the question. It says that the sum of the first n terms of an AP is given as a formula containing n, and there's another AP formed with the same first term and double the common difference of the first AP. What would be the formula for the sum of the first n terms of this new AP? How do we do this question? So the sum formula is given for us for the first AP. So if we put n equals 1, we can find out the sum of the first term, which is same as the first term itself, and that's equal to 5. The sum of the first two terms can be found by putting n equals 2, and that is equal to 60. S2 minus S1 will give us the second term, and we find that the second term is 11. Therefore, the common difference of the AP can be found as T2 minus T1, and that's equal to 6. Now we are required to form a new AP with the same first term. So we can take the first term as 5 and the common difference as twice the common difference of the first AP, so 2d, and that's equal to 12. So now using the sum formula, we can say that this would be the formula for the sum of n terms. So plugging in everything here, we find that it simplifies to 6n squared minus n. So the correct answer is option B. Alright, in this question, we have been given two different arithmetic progressions, and we are supposed to find out the sum of the first 20 common terms between them. How do we do this question? So the first AP is given to us. We can note that the common difference of this AP is 4. For the second AP, we can see that the common difference is 5. Now we can also see that the first common term is 11 by just observing the two APs, and we can see that the common terms will also form another AP, and that AP will have a common difference equal to the LCM of the common differences of the first and the second AP. So that would be the LCM of D1 and D2, which is equal to 20. Therefore, the sum of the first common 20 terms can be now easily found by using the formula, and this is 4020. The correct answer is option A. Okay, take a moment to read the question. It says that a man has saved 200 rupees in the first 3 months of his service, and every subsequent month he saves 20 rupees more compared to the previous month. Now we want to find out how many months it would take before his total savings are equal to 11040. How do we do this question? Well, we can write down his savings in this kind of a progression. So 200, 200, 200, and then 240, 280, and so on. So we can see that beginning from the third term, it is forming an arithmetic progression. So we can say that we can take the first two terms separately and the rest of the terms separately. So let us say that we need n terms of the second part, and this entire sum should equal 11040. So which means 400 plus the sum of n terms of the progression should equal 11040. And we have used now the formula for the sum of n terms of an AP. So it leads to this form now, and that is again simplified to this equation, wherein we have divided both sides by 20. Now simplification leads to a quadratic equation like this. This is obviously not so simple to factorize, but a little bit of trial and error, or maybe using the formula for the quadratic equation, we can find that n is either 19 or minus 28. Now the number of terms cannot be negative, so we discard minus 28 and take n as 19. And therefore the total number of months would be 19 plus 2, which is equal to 21. The correct answer is option D. That's it for this session.